In this video, I'd like to talk about the math question of the day for Friday, April 21st, 2023. And with this problem, we need to find the domain of the function f of x, where we have a rational function. And a problem like this might be seen in a pre-calculus class, though depending on the order in which you learn things, you might also see this in an Algebra 2 class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can work through this together. Now, assuming that you have attempted the problem, let's start working through it. And if you have suggestions for future questions today, feel free to leave those as comments. Now, when finding the domain, we need to know what the definition of domain is. And there are many ways to look at the domain of a function. One simple way to think about it is we are asking the question, which x values can actually be graphed or can be graphed? Since there are some x values in different functions that we can't actually plug into the function. The function might not be defined there, or maybe we're dealing with only real numbers, and by plugging in a specific x value, we might end up with complex numbers or imaginary numbers as our output. But a more general definition of the domain is the values of the independent variable that are defined for the function. So with domain, there are essentially two key issues we need to focus on, one of which is division by zero. So let's say, as an example, we have that g of x is 1 divided by x. There is one x value that we cannot plug into this function, and that would be an x value of 0. If we plug in 0 to our function g of x, we get 1 divided by 0, and division by 0 is undefined. There is no answer that we can actually define for this value here. So when dealing with domain, we're looking for x values that lead to division by 0. Those cannot be graphed. Those are not defined. The other example we can consider, which doesn't actually apply to this, would be some function like h of x is the square root of x. In this case, x needs to be 0 or bigger, since let's say if we plug in -1, we end up with the square root of -1, which is a complex number. In particular, it's the imaginary unit. Now, it is possible to extend our domain to include complex numbers, but usually when domain is taught, especially in high school, we're not including the complex numbers. So this is possible to graph, but not on the normal coordinate plane where we have the xy axes, and all of these values here on this coordinate plane deal with real numbers. If we're just dealing with the normal coordinate plane, the xy plane, then x values less than 0 would not be included in the domain because we won't be able to plot those. However, like I mentioned, there are more advanced techniques to actually plot complex numbers. It's just not typically taught in a high school class. And this would, of course, apply as well. Let's say if we had the 4th root of x, or the 6th root, or any even root, though for odd roots, we don't have to deal with this issue, since you can take, let's say, the cubed root of -27. This is a real number. This is just -3. So in conclusion, with domain, we're just looking for these two main issues: division by 0 or square roots of negative numbers. And I do want to mention, division by 0, that is never defined. Even if we extend our domain to include complex numbers, we still cannot divide by 0. And the reason why for that is a little complicated, and I've made videos on it in the past, but essentially, if you look at the graph of this function, if I just plot it very quickly, it looks roughly like this. If you approach 0 from the left-hand side and move along the curve this way, then notice that the function starts approaching negative infinity. So you might be tempted to say that this is equal to negative infinity. But if we approach 0 from the right-hand side, going in this direction, notice that the value of our function for, again, values of x that are just slightly bigger than 0 start approaching positive infinity. So in some sense, we can argue that division by 0 is equal to negative infinity, but in another sense, we can argue that it's equal to positive infinity. And it obviously cannot be equal to both, and there is no way to determine which one it would be. So we cannot define one specific answer to this, which is why this is undefined, or at least this is one reason why we would say it's undefined, but we could extend this argument further if we wanted to. Now back to our problem here. We need to find the domain of this particular function, and since we don't have any square roots, we don't have to worry about the square roots of negative numbers, but we do have division by our variable x. So we do need to look for cases where this denominator would be equal to 0. And you might be able to figure those out just by thinking it through, that x can't be 2 or negative 2, but if you didn't see that, it might be helpful to just set your denominator equal to 0. We can say that x squared minus 4 cannot be 0. Whatever is down here, it cannot be equal to 0. And from here, we just need to solve for x. So let's add 4 to each side. X squared cannot be equal to 4. And if we square root everything, we do need to be a little bit careful. This is technically equal to the absolute value of x. That cannot be equal to 2. And with an absolute value equation, we can split it into two different parts when this is a positive number or when this is a negative number. And the absolute value bars will flip it to positive, since absolute value is just asking how far is that number from 0. And we're looking for numbers that are 2 units away from 0, and that would be positive 2 and negative 2. Now usually when writing out our work with algebra, we will skip this part. It's implied once you understand it, but most students will just memorize that when you take a square root of each side to put plus or minus whatever is on the non-variable side. So we get x cannot be plus or minus 2, which again is what we may have seen by just examining this and thinking about whole numbers, which might lead to 0 for this denominator. And one other approach that I should mention is that you could factor this denominator into a difference of 2 squares, since that's what we have here. We have x squared minus 2 squared, and that would factor to the first one minus the second one, ignoring the squares now, multiplied by the first one plus the second one. And we can see that 2 and negative 2 would make each of these expressions 0. So the domain of our function is that x cannot be negative 2 or 2. And there are other ways to express domain, which I will mention very quickly. If we want, we can use interval notation. We can say that for our domain here, the x values start at negative infinity, go all the way to negative 2. We use parentheses to signify that negative 2 is not included. We use a union to add on our next set of numbers where the domain is valid, and that would be from minus 2 to 2. Again, we're not including those endpoints. If we use a bracket, that would mean that the endpoints are included. And we use another union to indicate our last set of numbers that work, that go from 2 to positive infinity. So this is our interval notation, and we could use inequality notation as well. Though with inequality notation, it gets a bit messy. We would have to say that x is less than negative 2, but bigger than minus infinity. We would have to add in that x could also be between 2 and negative 2, and then add in our last set that x is bigger than 2, but less than positive infinity. So we can write the domain in several different ways, and you can see the simplest is just talking about which x values are excluded.